So James, welcome. Salt, then seed oils, and now immunity. So you've had 3 books come out in the last, I don't know, was it 3 or 4 years? I think they've all done reasonably well from my understanding. And so for those that aren't aware of your background, I know you're a cardiovascular researcher. Can you give us a little background, James, on who you are, where you train, what your training's in, and then we can go from there?
Sure. Yeah. So like you said, my training is in cardiovascular research at St. Luke's Mid-America Heart Institute. I've been doing that for almost 10 years, and I serve as the associate editor for BMJ Open Heart, which is an open access cardiology journal in partnership with British Cardiovascular Society. I've written a couple hundred academic papers, primarily on nutrients and nutraceuticals for cardiovascular health. And you already mentioned my books, so I think that's a pretty good recap.
Yeah, so Salt Fix, it was Super Fuel, and this one's called what? The Immunity Fix, I think. I just got it, and I was thumbing through it. I haven't had a chance to read it all, obviously, but you got 200 pages of references in there, which I thought was, I looked at the book, I was like, wow, there's a lot of references. So do you know how many references there were? It's got to be at least 1,000.
Yeah, it's 2,415.
Yeah, so that's a lot of references for sure. So, I would imagine pretty much every sentence is tied to a reference.
Right.
Would be my guess. So, so let me just, before we dive into the book a little bit, I want to just, we're in a carnivore community here. We've got people, I'm just talking to them and they're saying, yeah, my back pain went away. And you've been a little bit somewhat skeptical, if not a little bit critical of that. What are your concerns about this carnivore diet? Because I think this is germane to this particular.
I'll be the first to admit you have actually helped me in regards to sort of pushing back a little bit and saying, well, James, where's the actual clinical evidence for your concern? And I think there's so many publications on the benefits of plant-based diets that if you're an evidence-based person, you're sort of almost inherently already against carnivore, and you're sort of like inherently biased against it. And so sort of that's where I was coming from, right? Is sort of like the literature, and in the real world, it doesn't really play out like that, right? And so I think, my primary concerns were vitamin C, copper, but you can still get those things from animal foods. And there does seem to be a lower need for some of these nutrients if you are reducing your carbohydrate intake. I think the main issue was manganese for me too. That one's sort of hard to get on a carnivore diet, but again, we don't know how much you really need when you're essentially not consuming carbs. So in all honesty, the concerns are more theoretical, but calcium is also a potential nutrient of concern, which you can just get from mineral water, right? You can get drinking certain mineral waters have calcium and magnesium. So,
yeah, well, I think the dearth of science, and I understand the concern, there just isn't a lot of literature on people eating all meat diets outside of historical references. There's very little, and we're trying to change that, as you're probably aware, trying to get some studies. I know Ludwig out of Harvard has got one with Belinda Leonard that they're in publication or going to be publishing, and then we're fundraising for an interventional trial. So, I understand the concern, and like I said, in the meantime, we have, thousands of people that are reportedly, doing pretty well so far. But let's talk about, obviously a lot of people have been talking about the immune system. We're in the midst of a global pandemic. I know some people have skepticism about, about the true nature of that or not. But regardless, we are constantly faced with viruses, bacteria, fungi. Our immune system, that's how we've evolved for years. And it's an extremely complex topic, as I'm sure you've discovered. And it is also probably something that we don't fully understand yet. I would think that's fair to say. I remember when I was learning about the immune system in medical school, and it's extremely complicated. And I'm sure in the intervening 20 years since I really looked at this in detail, it's probably gotten more complicated. But what sort of made you interested in researching this, and what have you discovered?
So we published a few papers on sort of what we think is driving a lot of the inflammation and clots with COVID-19. It seems to be driven by something called NADPH oxidase, which is the main producer of superoxide anions. And essentially, what we discovered in regards to why we think people have bad outcomes with COVID and why other people don't comes down to essentially two different things. People who don't respond well to COVID have a reduction in their own endogenous production of type 1 interferons, which help us interfere with the virus. And essentially, having poor metabolic health is going to lower your own ability to produce these type 1 interferons. And then the second is there's this lymphopenia, like this reduction in your adaptive immune cells, right? B cells and T cells are diminished and their cytotoxicity is reduced. And essentially what happens is instead of your CD8 T killer cells killing the virus in a nice silent way, your innate immune system has to sort of take over a little bit more, and it kills the virus in a more pro-inflammatory way and also kills healthy bystander cells. So if your adaptive immune system, like your CD8 T killer cells, don't function well, now you have to start killing the virus in a more pro-inflammatory way. And so those are the two primary things that we think is happening in regards to what's driving poor COVID outcomes.
Yeah, and it's interesting with the clotting stuff, because there's some people that will propose. I mean, there's going to be Malcolm Kendrick, who's very controversial. Will propose it. One of the driving, if not one of the main driving mediators of cardiovascular disease is more of a clotting sort of issue, or thrombogenic type of system. I don't know if there's any overlap with that being an immune system as well.
There is. So essentially what our paper showed is that there are ACE2 receptors also on your endothelial cells in the vasculature. And so when the virus enters in your endothelium, it causes massive inflammation, which then upregulates tissue factor, and that causes clotting. And that's why you see on autopsy these pulmonary clots in COVID patients. And so it has to do with where ACE2, which is the receptor that SARS-CoV-2 enters into our cells, is highly expressed in the lungs, in the enterocytes, right, in the intestine, and then also in your endothelium. So those seem to be the three organs, so to speak, that are primarily targeted and damaged by this virus.
All right, let's talk about, again, your book is fairly comprehensive. It talks about a lot of angles in the immune system. Can you just kind of give us some general sort of, this part, what does it take to have a healthy immune system?
So essentially, one of the biggest associations with poor COVID outcomes is low vitamin D levels, which that could mean lack of sunlight. It could also mean more comorbidities, but these studies also adjust for confounders like age, comorbidities, gender, things like that. And you still see if you're severely vitamin D deficient, like you have a level less than 12 nanograms per ml, you're at a 15-fold higher risk of dying from COVID. If you have vitamin D levels less than 30 nanograms per ml, you're at a 2 to 3-fold higher risk of dying compared to having levels of 30 or above. And even the risk of being tested positive for SARS-CoV-2 goes up by about 2-fold if your D levels are, essentially deficient compared to 55 nanograms per ml. And we know 50% of the global population is either vitamin D deficient or insufficient, and it probably has a lot to do with either lack of sunlight or lack of eating animal foods, because vitamin D is extremely difficult to get in the diet unless you're consuming things like cod liver oil, fish, or eggs. And very few people really consume enough of those foods on a daily basis to have sufficient levels of vitamin D.
I had 18 eggs yesterday. Does that help?
Well, what's so funny is like your diet, if you are heavy on eggs, literally one of the most nutrient dense foods. And the nutrients in eggs are probably some of the most nutrient deficiencies that we're seeing in COVID-19 patients, being selenium, right? Zinc, vitamin D, and then, vitamin D and even vitamin A as well. So those 4 nutrients, which are very high in eggs, are typically deficient in these patients. So it's kind of interesting.
Let me ask you, this is one thing, because I've looked into some of this stuff, and I look, back into the early literature, and they look at, they were looking at serum vitamin D levels among Inuit, and they found 2 populations, and they were both relatively low in vitamin D. presumably because they're in such a, the polar environment where sunlight is at a premium, particularly in certain times of the year. So they had low levels of vitamin D serum. And one group whose diet included, their traditional diet of marine mammals and terrestrial mammals, didn't have any sort of vitamin D deficiency syndromes like rickets. But another group had the same low serum levels, but they were eating flour, sugar, canned goods, and they did develop rickets, even though their serum levels were the same. Do you have any idea why that might be the case? Is there other things at play that are going to impact vitamin D? Does certain other foods use it more? Or, I mean, how are we seeing that?
Yeah, that's a good question. So essentially, when you measure vitamin D, you're not measuring the active form, which is calcitriol typically. And so you can have quote unquote normal vitamin D levels, but if you're not able to activate vitamin D to the active hormone calcitriol, that's actually what is doing all the magic in the body. And that requires good magnesium status. And the other thing too is we see with African Americans, they have lower levels of vitamin D, but they have higher levels of free, unbound vitamin D. So essentially, you also need to know, just like with hormones, right? Are they unbound or are they bound? And so that also determines how well that either nutrient or hormone is working in the body.
Yeah, and I assume back in the 1920s, they had a lot less sensitive assays, and they probably couldn't measure as much things as we do today. You talk about magnesium, one of the things that we see that magnesium, and you probably are aware of this, is deficient in a lot of people, or it's not as effective in a lot of people. And I want, magnesium being a significant cofactor in carbohydrate metabolism, there's some thought that the more carbohydrates you eat, the more magnesium you need to have to process that. We've seen also with absorption rates, we've seen that with zinc now with the RDA. If you eat more phytic acid, you have to have a higher zinc intake. I think if you eat 1,000 milligrams of phytic acid, then you need to double your zinc intake. And if you're at 2,000, you have to triple that. So, I wonder if the magnesium issue, again, all these things kind of work together, as you know. So I wonder if that's part of that equation.
Yeah, it absolutely could be part of it. I think, sort of the main issue with magnesium is insulin resistance, because if you're not insulin sensitive, you can't get magnesium into the cell because it's a nutrient that is insulin sensitive and driven into the cell by insulin. Same thing with potassium. So I think if you're fixing insulin resistance on a carnivore diet, your need for magnesium is dramatically going to go down. So that's number one. Number two, the drop in insulin levels is going to cause you to spill less magnesium out in the urine. So again, if you're fixing metabolic syndrome with a carnivore diet, you're automatically going to need less magnesium if you're improving high insulin levels. The only issue with magnesium, if you're comparing carbs, fat, and protein, is all three nutrients. The more you consume, the more magnesium you need. So the higher protein intake, the more magnesium you need. The more fat you consume, the more fat binds to magnesium and calcium and reduces its absorption. So both carbs, or all three, carbs, protein, and fats, can sort of increase your need of magnesium. But again, if you're lowering your overall oxidative stress and insulin levels, that is by far the most important thing when it comes to utilizing magnesium.
All right. So if you were to, obviously we're seeing obesity, we're seeing type 2 diabetes particular, and in age, all of these things seem to negatively impact our immune system. What sort of typical steps can people take, to fix those things? The general things I talk about: diet, exercise, sunlight, good sleep. What are the things that maybe people aren't aware of that would not be common sense? Some of this is common sense in my view, but.
Well, one thing that you and I both perform is what's called hyperthermia. We go into our saunas and we boost core body temperature. And essentially that's your first line defense against an infection, is boosting core body temperature through a fever. But you can do that through either exercising in the heat or with multiple layers of clothes on and boosting core body temperature, or you can go into the sauna and essentially you're hacking your own evolutionary ways to fight viruses, which is releasing heat shock proteins. And essentially how this works is, in order for a virus to replicate, it has to access your own cell. And then what ends up happening is it has to export its ribonucleoprotein complex out in order to replicate, okay? So M1 protein has to dock onto the complex, though, in order for it to export out. Heat shock protein 70, though, can dock on and prevent M1 protein from binding. So it prevents the viral export. So this is how we think sauna works. And numerous, at least a dozen prospective studies have shown people who, do sauna sessions 3 to 5 times per week are at a lower risk of influenza, common cold, pneumonia, and other respiratory diseases.
Yeah, and I actually, when I was glancing through the book, I think you did have a section on sauna, and you talked about infrared versus traditional sauna. I've got an old house that we bought that came on the sauna, and it's one of these old ones that goes to about, I think I've gotten it up to 220 degrees, and I'll sit in there for about 30 minutes, which is pretty damn hot. But I'm used to it now. But is there a major benefit one or the other than one you don't have to be as hot in the other one? What's the difference on IR versus traditional sauna?
So essentially, the main benefit from sauna is boosting core body temperature and releasing heat shock proteins. Infrared does have an additional benefit of you're getting infrared rays, which if you look at the animal studies, where they'll either put these animals on a hot pad, mimicking like a traditional sauna, or they'll put them on a hot pad plus infrared, you do get an increase in more nitric oxide, more vasodilation, because of the infrared waves. But besides that, you're still probably going to get the same type of immune support from both.
Yeah, and so I know I think there was a study, it was out of Finland, I think, looking at longevity or health outcomes in people that regularly sauna. And the question was, these people are already at the gym. Is it confounded by the fact that they may be exercising or more, there's so many potential confounders. Maybe they're more wealthy. We always see that wealth seems to drive that. And, a lot of people can't afford a sauna, it's particularly if they're home or have access to them. So, if it's confounded, but do you think there's significant evidence outside of that in human studies?
Yeah, I do. So there is a human study. It was a 50 patient study. They split them in half. Half the population got sauna sessions. I believe it was 3 times a week. The other half did not. And the patients who had access to the sauna had a 50% reduction in common colds. And then we have definitive animal studies where if you heat shock them prior to giving them lethal bird flu or other lethal viruses, it significantly reduces mortality, lung pathology, and viral replication. So animal studies have confirmed that absolutely it has antiviral effects if you go into the sauna or you boost core body temperature. And even a human clinical study supports the prospective studies as well.
There's a question in here about blood pressure in saunas. Is it contraindicating people that have high blood pressure? Is it helpful for people that have high blood pressure? I know that's not exactly immunity, or there might be.
No, that's a good question. So essentially, when you go into a sauna, you're activating hormesis, right? So you're stressing your body out. So initially, you're going to see a rise in heart rate and blood pressure, because of the activation of the sympathetic nervous system. But then the recovery after the session, you have an overactivation of the parasympathetic, and that drops blood pressure. You see vasodilation, even in the sauna too. And so essentially, sauna sessions have been associated long-term with lower blood pressure, better parasympathetic to sympathetic activation.
I just kind of equate sauna to exercise. I think it does very much of the similar things, and whether it's because there's a difference between anaerobic and aerobic exercise, particularly in intensity. But I treat sauna as just basically an additional exercise session. And we know that exercise, the same thing, you see a rise in blood pressure, you see a rise in blood glucose if you're intense enough, and then those things all improve, and then they improve over. You see this benefit for, I don't know how many. I know intense exercise, you might see an effect for 24, 48 hours. Is sauna similar to where we see these reductions in improvements in glycemic control, blood pressure, so on and so forth?
Yeah, exactly. So heat shock proteins are also insulin sensitizing, and so is nitric oxide, which is boosted with sauna sessions. And nitric oxide has extreme antiviral effects. Like, there was a study published in Beijing, China during the SARS breakout, and they rescued patients with inhaled nitric oxide. And so when they looked at the lung infiltrates the pathology and the infiltrates were significantly lower, and their dyspnea was significantly improved when they gave them inhaled nitric oxide.
Let's talk about the duration. I think your book, I think you said 30 minutes was kind of that point where you get this diminishing returns afterwards. Is 60 minutes? 60 minutes. Okay.
And that's if you're going extreme, heavy exertion. So it's not that you can't or should not ever, do heavy exertion for over an hour. It's just that you are increasing your risk of upper respiratory infections when you do that. And that's just like anything, right? If you put too much stress on the body and you don't have enough time to recover, you're going to be at an increased risk of upper respiratory tract infections. But we had potential things in the book that could help offset that, like beta glucan, selenium, zinc, and copper, some other strategies as well.
Yeah, I was kind of talking about sauna. Is there a sauna time frame?
Oh, sorry. Yeah. So yeah, you're right. About 30 minutes. You nailed it. Is really where we see probably if you hit 30 minutes, you have a huge release of heat shock proteins and really good cardiovascular benefits. As you go beyond 30 minutes, you're starting to sort of tax your mineral status, right? You're losing a lot of copper and salt and sweat, and you're sort of, once you hit the hour mark, you're definitely more in sort of this like a heat stroke type of issue.
Yeah, while we're talking about minerals, I want to go back to your expertise on salt because, as many people on low carb diets, and obviously a carnivore is a low carb diet, we see that the often the recommendation is increase your mineral intake, whether it's sodium, magnesium, potassium to some degree, and then particularly around exercise. But we do, is there some? I mean, we see that during the transition period. There's this keto flu that people have, and they treat that with increasing fluid and electrolytes. But then I think some people continue that. And so is there a point where you kind of compensate and then there's a re-equilibration point where you don't need quite as much later on? Is that fair to say?
I think that's pretty fair to say. So the first 1 to 2 weeks, you start losing an extra 1 to 2 grams of sodium due to the, transition from a high carb diet to, let's say, a carnivore diet. So most people find out that they do a lot better in regards to less keto flu, less dizziness from going from a seated to a standing position by adding an extra teaspoon of salt for that first couple weeks. And then what's interesting is glucose helps to absorb sodium. So even chronically, when you are on a low carb diet, you don't absorb sodium as well. And so that's why a lot of people still seem to need more salt, even chronically, on these ketogenic and carnivore diets.
Yeah, I mean, a lot of those, the glucose transporters, they have a sodium co-transport, if I'm not mistaken. I'm trying to remember my stuff from years ago.
Right on. You got it, Sean.
Yeah, that's been a while. I looked at that stuff, but interesting. So, this has been so controversial with the coronavirus, but what do we know about, one, minimizing, assuming a lot of us will get it. Many of us probably had it and don't even know we've had it, probably, like many viruses. I mean, we're probably exposed to, thousands of viruses every day on a daily basis would be my guess. But how do we, can we effectively minimize the likelihood of, outside of, some people are obese and that's not going to change in a week. But are there things we can do just on a day-to-day basis while we're improving our overall health, which is maybe a 6-month, year-long process, to minimize the likelihood of either acquiring the disease or succumbing to it or getting sick to it? What are the things we can do?
It's a good question. So I'll sort of preface it and say nothing has definitively been shown in regards to those questions, except for dexamethasone, which only in COVID patients who need sort of respiratory support, there was a randomized trial that dexamethasone reduced 28-day mortality. There was a preliminary small study showing that an activated vitamin D analog significantly reduced going to the ICU in a small pilot randomized study. Essentially, people who got this activated vitamin D analog, it was essentially a partially activated vitamin D supplement or medication. Those individuals, only 2% ended up in the ICU when they were hospitalized with COVID, whereas 50% of the placebo patients ended up in the ICU. Now, you and I both know that seems to be way too dramatic of a benefit to probably be real. You know, a 25-fold higher risk of ending up in the ICU, that seems pretty dramatic to me. And you typically see that with tiny studies. But as you sort of further test things out with larger studies, those huge benefits that you find with small studies tend to usually go down. But there might be something to vitamin D. Still don't know yet. What's really interesting is there's been 2 studies that have come out that have done retrospective data on what type of, you know, supplements is associated with a lower risk of either testing positive for SARS-CoV-2 or associated with a lower risk of mortality. And melatonin supplementation keeps showing up as a dramatic supplement that is associated with a lower risk of dying in intubated COVID patients or even testing positive. And melatonin isn't just like this hormone secreted by the brain at night. It is continually secreted through red light being hit through the retina through sunlight. And it's a master antioxidant. It can cross into any cell. It concentrates in our bone marrow to protect our stem cells and immature immune cells. And so really what you can do on a daily basis to support melatonin is getting sunlight in the morning, throughout the day, trying to get it in the evening, and avoiding light at night. That's one potential way of supporting melatonin.
Yeah, I have 2 dogs, and they're great health tools because I take them for a walk every morning for about an hour. I usually have about a 4-mile walk in the morning first thing when I get up. That's how I start my day, you know, pretty much every day, because, you know, the dogs kind of help you do that. So dogs are a good thing. Let me ask you, because vitamin D supplementation, you know, for years we've got studies, lots of studies showing it didn't make a difference, doesn't help with certain outcomes. People are saying we weren't using enough, we weren't using the right kind. How does vitamin D supplementation compare to, let's say, getting it from food and then comparing it to sun exposure? How do those things work? And can artificial sun exposure, i.e. tanning beds, things, I know that's a controversial topic, can that also produce a vitamin D effect?
Good question. So tanning beds are UVA, and it's UVB that produces vitamin D. So typically tanning beds aren't going to raise vitamin D. Spurdy has a tanning lamp that's more UVB than typical tanning lamps, and that may actually raise vitamin D levels a little bit. I will tell you, it's very difficult to get above 35 nanograms per ml solely through sunlight, because I tested my D levels. I wasn't consuming a lot of vitamin D in foods. I wanted to test this out and see like what my D level was if I wasn't consuming D foods and I wasn't supplementing with D. And I was getting a ton of sun. I was probably getting like 30 minutes of good sun every single day. And my D level was only 33. So it was sufficient, but it was on the, you know, the lower end of sufficiency. I wasn't like 50 or 70. So for people to be in that level, either I'm genetically not predisposed to having high levels of D through sunlight, or in order to really hit 40 and 50, you need to be eating good animal foods or cod liver oil or supplementation. So that's just something interesting that anecdotally tested on myself.
Yeah, and let's just say, you know, we're gonna, you know, supplement. Is there one form that's better than another? Is there something you need to do in addition to it? I know you mentioned magnesium, but how do you make that work well?
Yeah, that's a good question. I think is just like with everything, nutrients work together, not only through absorption, but through activation. And it's always best to try to get nutrients through food. So I think vitamin D through fish, through eggs, through cod liver oil is probably better. And it's more obviously matched evolutionarily to what we would have gotten for millions of years compared to a D supplement. Now, if you just take vitamin D and your magnesium or your vitamin K or your vitamin A is low, you can sometimes make things worse because you start hyper absorbing calcium and you don't have the magnesium and the K2 to keep it out of your arteries and into your bones. So a lot of people just like hyper supplement with vitamin D and they're severely deficient in magnesium and K2 and vitamin A, and they can make things worse, which is why sometimes these studies, when you just give one nutrient, doesn't really show a ton of benefit unless you're severely deficient. So just to give you an example though of how beneficial vitamin D supplements can be if you are deficient, a recent BMJ meta-analysis in 25 clinical studies, about 11,000 human participants, the number needed to treat was 4 to prevent one upper respiratory tract infection in people who were severely deficient. So if you're really deficient, of course, a vitamin D supplement is going to show some benefits, but ultimately you want to get it through food and get all the other nutrients that are important as well.
Okay, well, let's talk a little bit about exercise. I assume you cover that in the book. What is a dosing of exercise that we like to talk about, and what type of exercise?
Yes, so I kind of messed up and I thought you were talking about exercise when you were talking about sauna, but essentially exercising moderate to intense for about 30 to 60 minutes, 5 days a week is associated with about a 43% lower risk of upper respiratory tract infections. When you start exercising at very high intensity over an hour for about 4 days or more per week, there's about a 2 to 6-fold increased risk in upper respiratory tract infection. So, but that might not happen if you're supplementing with things like beta glucan and you have a really good nutrient status. Because again, right, these studies are extrapolated from typical standard Americans. So maybe you can get away with exercising at more of a higher intensity for over an hour and not have an increased risk if you're in good metabolic health. I don't think we really know that.
Yeah, I mean, just for the record, I don't usually I do very intense exercise, but it's usually 30 minutes or less. And most of the other stuff is kind of walking, which I don't really count as exercise. I mean, maybe some people would, but I don't. Let me ask you about, autoimmunity. Obviously, the immune system has a role in autoimmunity. Can you talk about how that sort of plays out? What do we talk? I know you cover that a little bit in your book, I know.
Yeah, there seems to be some type of autoimmune condition going on in patients who are experiencing severe COVID cases. So if people who are having a poor COVID outcome, about 10 to 15% have autoantibodies to their own type 1 interferons, whereas you only see that in 0.3% of people who have good COVID outcomes. So essentially, there's checkpoints on your B cells where they're not supposed to, sort of have these autoantibodies against yourself. And a lot of that is regulated by vitamin D and vitamin A. And so if you're deficient in those two vitamins, again, which are highly concentrated in animal foods, right, you are probably at a higher risk of having these autoantibodies to your own type 1 interferons that help you fight viruses. So those studies are just coming out, and it's really interesting to see that kind of play out.
Yeah, perhaps I should have done this at the beginning of the session here, but can you just kind of how does our immune system work in a general overview for laymen? Because you're using a lot of terms that I suspect a lot of people are like, I don't know what that is, but let's say I'm presented with a challenge, an antigen challenge, and I maybe don't even know what an antigen is, but how does our immune system work? And from a let's put it at an 8th grade level, just so we can kind of maybe start there or end there, perhaps.
Sure. So I guess your immune system starts with your skin as a physical barrier and your mucous membranes as well as a physical barrier, which is tightly controlled by riboflavin, vitamin A, and vitamin D. So 3 nutrients that are highly concentrated in animal foods are sort of your first line physical barrier defenses. And in order to build those, you need those 3 nutrients in particular. And in order for a virus to infect you, it actually has to sort of basically drill through your mucous membranes and sort of get access to your own cells. And how the immune system works is your bone marrow produces stem cells, which eventually turns into your immune cells. And you have sort of, quote unquote, we've broken it down into 2 systems: your innate immune system, which responds rapidly, like natural killer cells and macrophages and monocytes that are a little more pro-inflammatory in their killing, and white blood cells too. And then you have your adaptive immune system, which actually there's parts of that immune system that actually act like the innate immune system. And that would be your CD8 T killer cells. And essentially your adaptive immune system is made up of B cells, which produce antibodies, right? These immunoglobulins against these antigens, and sort of tag them And that helps then complement in the immune system to target viruses. So B cells help, the antibodies to attach to the virus, and that signals the immune system to come in like natural killer cells, CD8 T killer cells, to kill the virus. And sort of kind of what I covered high level, where it goes wrong is as we have this immunosenescence, this dysfunction of the immune system, whether from metabolic syndrome or aging, your production of your B and T cells go down and their function goes down. And then now you have to rely on more of your innate pro-inflammatory immune system to kill the virus. And you also don't have these type 1 interferons, which are basically cytokines, that really enhance the whole immune system. And so that signal goes away with age and with metabolic, dysfunction.
Yeah, and one of we initially when this coronavirus or COVID-19 thing came in, we started hearing more about this cytokine storm that was not, and that's obviously related to immune function. So how is that pathologic, and how can you prevent that from happening? Is that an overactive immune system, or what's going on there?
Yeah, so it's an underactive adaptive immune system and an underactive type 1 interferon response, forcing the pro-inflammatory killers to do more of their work. And when you have a reduction in type 1 interferons, you're essentially now dealing with a higher viral load. And so now you have to kill more of your own healthy cells. So essentially, the reason why children clear the virus so quickly is they have such a strong immune system and they have such a robust first response to it. Whereas in the elderly, their first response is terrible. Their type 1 interferon production is horrific and their viral load dramatically goes up very quickly. And now they have to kill their own cells in order to clear the virus. And essentially, when you do that to the type 2 alveolar cells in your lungs, you really start damaging your lungs, which can then lead to sepsis, and then that can lead to death.
This is one thing that's, I think, a challenge. How do we assess if we have a healthy immune system? Is there a test we can do other than saying, I rarely get a cold, I feel good all the time? Is there some kind of objective way to assess if you've got a healthy immune system?
I don't think so. I mean, there are certainly clues, right? We know you can get absolute neutrophil counts. You can get absolute lymphocyte counts. And if they're low, obviously something's wrong. But there's not an easy, simple test that tells you how well your T cells are cytotoxic. You know what I mean? Like there's no simple test to really measure how well your immune system is functioning. I think the simplest tests are, do you have metabolic syndrome? So do you have slightly elevated blood pressure, plus blood glucose, plus a waist circumference that's elevated, high triglycerides, low HDL? You have 3 of 5 of those. That's a great assessment that your immune system probably isn't doing well.
Yeah, I mean, I think, again, that you can kind of look at people and say you probably don't have a strong immune system, but that is, that's a challenge, I think, is trying to, these things that maybe they're not subjective, but they're so complicated to measure. It's hard to find one little thing. One of the things that I've often seen, and correct me if I'm wrong, but we do see, and you're talking about the different individual white cells, but a generalized, if we look at the normal range of white cell count, and I can't remember, it's like 4 to 15 or something like that. I can't remember that, or 4 to 12,000, something like that. When you tend to be lower, it's often associated with lower inflammation states. So how is that what you've seen in the past? I see a lot of people that come in with white cell counts of 4 or 5, pretty on the low end of normal. And then when we see higher ones, it's often associated with inflammation. So how do we, is there a problem with what's the sweet spot for white cells?
Yeah, that's a good point. So if you have an overactive immune system, like with inflammation, or you have an active infection, you're going to see white blood cell counts that are higher than normal, supraphysiologic. And so that's probably indicative of either inflammation or an active infection. So what you're saying is that if you have a slightly, like still in the normal range, but sort of on the lower end of normal, that makes a lot of sense, actually, that would be associated with low inflammation.
Yeah, that's what I tend to see. I just, I mean, you wrote this book and you had a co-author. And I mean, for years, I thought the guy's name was Slim, Slim, but I guess it's SII. So I'm glad I saw it to clarify. And he's Scandinavian, I would assume in the name. I don't know where he's from, but who's the co-author?
Yeah, he's from Estonia, yeah, Simland.
Oh,
So he's a biohacker, and he does a lot of things like I do, right? Red light therapy and sauna and all these things. So
yeah. And what the book is now out. It's available, I guess.
Amazon.
Where Amazon? Okay. Is it released in other languages yet, or is that something that is to come?
Not yet. Not so. It's on Kindle and it's paperback. We're thinking about potentially doing an Audible, and then I'm sure eventually there'll be a few other languages that come out, but not yet.
Yeah. Okay. And then just for people that might have an interest, what's the overview of the book? Just kind of can you give me a 3-minute synopsis of what's in there? I mean, I know there's a lot of references, and for people who want to read thousands of references, that's there. But just
Right.
is it kind of the quick overview what's in the book?
Sure. So I think your listeners will appreciate that we do have a food pyramid, right? And the base of that food pyramid, it's essentially an animal-based diet is what we both consume and recommend, because animal foods are so much more nutrient dense and are higher in the nutrients that are deficient in a lot of these COVID patients that aren't doing well. So in regards to diet, it's an animal-based diet that we're promoting. We do promote some plant foods though as well. Obviously exercise, good sleep, sauna, potentially cold shock therapies too, like cold plunges if you're healthy. We also cover a lot of supplements, nutraceuticals, and nutrients that are low in COVID patients. We sort of covered melatonin a little bit. And essentially it comes down to making your body more resilient. What can you do to induce hormesis, whether it be sunlight, sauna, exercise, things of that nature, because that ends up making your own cells more resilient.
Yeah, let me touch on cold, because we've heard a lot about sauna. I mean, there's obviously you're probably familiar with the guy named Wim Hof who has been making cold therapy popular. But is there significant differences in how you decide? Because a lot of people are like, hell, I'd rather sit in the sauna than go jump in an ice bath. So how do are they, if you do one or the other, is it the same benefit, or do they each have different sort of reasons for doing them?
So when it comes to an actual infection, RNA viruses, they're very elegant, but they have one link in their chain, and that's heat. Usually they don't do well with heat. Even raising your core body temperature from 98.6 to 102, that happens with a sauna, can dramatically reduce replication of numerous RNA viruses. So the colder you are and let's say you have a virus and you don't even know you have it, right? That's not good. That's why viruses propagate in the cooler areas, right? Your sinuses, right? Your nasal cavity. That's where they like to kind of spend their time and grow. And it takes them a longer time to get to the warmer areas. So when it comes to immune support, cold is not nearly as good, let's just say, to simplify things, than heat. And if you think about it, Sean, humans are heat adapted. So we are really good at cooling off, which is probably, helped contribute to who we are as human beings, because we could persistent hunt in the savannas for hours. We would just tire animals out, right? Because we can sweat. Most animals can't sweat. Even horses can't sweat like we can. We just dump heat like crazy. And so we are sort of evolved in a very hot, right? Sub-Saharan type of Africa type of setting. So our whole cellular functions are matched with heat. And so we would have adapted things like heat shock proteins, right, through this millions of years, hundreds of thousands of years of being in the heat. Cold is something more new when we sort of exited out of Africa and went more north and things like that. And there are things called cold shock proteins, and they do seem to have some insulin sensitizing benefits and brown fat activation. However, there's exercise is something that we know is good for us, but if you do cold therapy after exercise, it's like taking high dose antioxidants. You'll blunt a lot of the benefits. Whereas if you hit the sauna, you're sort of enhancing the benefits of exercise. So there's a lot more data with heat versus cold, and that just matches evolutionarily, how we live too.
Let me ask you about, this sort of, we've got this disinfect everything sort of thing. And I know people have talked about, we've weakened our immune system by the fact that we don't expose ourselves to, the typical amount of, challenges that we would have been exposed to. I mean, I would assume there were lots of viruses and bacteria and things floating around for, millennium, if not millions of years. And now, people are, just scrubbing everything, disinfecting everything, not touching things. Does that have a potentially negative effect on our overall immune system's robustness?
It 100% does. So how the immune system works is you have to train it, and how you train it is by introducing pathogens. And essentially that's how vaccines work. You introduce part of this, right, virus that's somewhat declawed, and that causes your immune system to respond and develop antibodies to it, and T cell and B cell memory recognition, which is actually more important than antibody response, because T cell, B cell recognition, it lasts for decades potentially, whereas antibody response only lasts for months. And then of course it depends on what type of antibodies even being responded. Is it a neutralizing antibody, which is good, or is it a binding antibody, which might even be bad? But regardless, how you train your immune system is through activating these pathogen receptors. So you either take something like the cell wall of yeast beta glucan, which tells your immune system there is some foreign molecule, and that activates the immune system and strengthens it, or you actually get a pathogen or a virus, and then your body responds to it in a robust way. So yes, how we train our immune system is through getting these viruses or taking some type of structure that represents a pathogen to stimulate the immune system.
Yeah. So, I mean, outside of eating dirt, but let me ask you, I'm gonna, we're talking about individual response and individual immune systems. And I know this next part may be controversial, but what are your thoughts on herd immunity? We've got different responses to the way we've treated this pandemic. Different countries have yet different strategies. We have vaccines that are being proposed. I know Pfizer just states that theirs is 90% effective, and I think it was on a small number of patients they saw that. From a population standpoint, what is the way to go in your sort of opinion? I know this is a little controversial. Yeah,
it is totally. Let me give a good example. When the 1918 Spanish flu hit, right, after about a year and a half, essentially everybody was quote unquote immune to it. Like, you could still get it, but it wasn't killing you anymore. So the idea with herd immunity there is that eventually, if you survive it, right, you're going to be at a much less risk of dying if you get it again. The problem is that RNA viruses mutate constantly. So that's why everybody keeps getting the flu, right? You're never like completely immune to the flu because it keeps changing. So that's what's going to happen with coronavirus. They're going to keep needing different vaccines. Most of them are going to have to have 2 or 3 doses to even work. And the idea that once you develop herd immunity, you're completely fine. I wish that was the case. However, the virus is smart, will keep mutating. However, I think if you are exposed, think about it. Your immune cells are going to see that similar structure. And it's, in my opinion, this is not proven. If you are exposed to, let's say, this coronavirus, once it mutates, you're probably at a better, more strong state to handle the next mutation. That makes sense.
Yeah, no, it does make sense. And so it's kind of,
controversial. So
I know it's controversial, and you got to, like, unfortunately, you're not even allowed to discuss this stuff without being kind of shut down to some degree. Have you had any sort of pushback from talking about this? Has it been something that you've writing a book about this? I don't know if there's any kind of significant pushback, unless you're discussing things that, telling everybody to get a vaccine or something like that.
Right. We completely don't even mention vaccine for that very specific reason. We were very careful with how we worded things. And, basically we never say this treats or prevents or cures anything. And so I think because we came from a standpoint of here's the science, here's our interpretation, and you can take this information and apply it how you think it's going to improve your immune system. I think it's been really well received because of that approach.
All right. Was there anything else we left out, James, that you want to mention about the book or anything else? And if not, then where? Because we've just kind of got through an hour, and I think there's a lot more we could talk about. But where do people find the book? Where do people find you? So on and so forth.
Sure. So the Immunity Fix is on Amazon, and my website is Dr. James DiNic, DINIC.com. And I'm on Instagram and Twitter at Dr. James DiNic.
Perfect. All right, guys. Well, James, thank you very much for popping in and saying hi. Hopefully, people will at least look into, fixing their health and fixing their immune system. Because I think, we're going to be, I'm sure we're going to be exposed to more and more viruses and pandemics. And I think we've got these one of the problems we have is these population centers that are just, we've got cities in Asia that have 25, 30 million people in them. And I think the population densities are just immense. And I think that's a huge, huge issue, I think, and that's not going to go away anytime soon. So I think we need stronger people. All right. Thanks, everybody. We'll see you guys tomorrow. And James, good to see you again. And hopefully everything's well with you. And I look forward to talking to you again sometime.
Thanks, Sean. I appreciate that.
All right, guys. Take care, everybody. Bye-bye.
Take care.